Hello and welcome to a brief demonstration of Carbonite Migrate. In this use case, we're using what we call full server migration. It's the ability to take a system, Linux or Windows, running in one environment and bring it to another environment. Our solution is hardware agnostic. In this case here, I'm going to demonstrate how I can take a VM running in AWS and bring it over to GCP. The same premise applies to physical servers, applies to private cloud, public cloud, anything. As long as it's supported operating system, you are able to do a lift and shift. So what I have here is I have a system running in AWS that's CentOS, pretty straightforward environment, nothing fancy about it. And then I have another system running in GCP. As you can see, they're very similar from a networking perspective and from a disk structure perspective, right? Now, once the application is installed as a service, then you'll be able to perform a migration job. What's nice about our solution is that the license is source only, so all you have to do is worry about purchasing the licensing for the source, and it starts at 60 days and 90 days, depending upon your migration process that you need, and also alternatives are available as well if you need to do more longevity. But once the software is installed, it will be node locked, and it will expire at a particular date based upon the activation. So it's got 60 days from activation. Once that happens, you're going to basically select migrate. You're going to select a full server migration job. What's nice about our solution, you do have the capability of adding exclusions to the environment. So in this case here, if I do not want to bring this data volume over for some reason, maybe it's backups or it's redundant or it's scratch, I can actually add a rule. It's going to say, okay, I'm going to not bring that data over across the wire. Gives you the capability of trimming out data on your production systems that you know you don't want at the target location. And you're able to do that. All we're looking for is the volumes to be logically the same from a mount point perspective and have enough free space on them to accommodate the data that's in use. Next, you're going to select a target. From here, it's going to read the source system, and it's going to create a whole bunch of default options. Most of these you will keep. The fact that we're going across a wired area network, we want to retain the target IP information because it's in GCP. The AWS information is not going to operate in GCP. The other thing here is we're also going to be traversing across a public IP here. So I'm going to take the public IP address of the AWS system and apply it here. You wouldn't have to do that if you have site-to-site VPN between the two locations, but most cases you're doing this for migration, so you're not going to have that. Not a problem. You can actually enable our AES 256 encryption, so you can actually send the data across the clear internet without any problems. You also have the capability of creating a bandwidth throttle. So for some reason you want to create what I would call poor man's quality of service. During the day, you want to minimize what traffic the engine might use and open it up at a different time. Now we're byte level. We're not going to saturate any network. We're not a data mover in a bulk data transfer perspective. Our goal and objective is to move the data in a data consistent way to ensure right order fidelity so the target system is in a great state. Specifically when you're dealing with databases, you have to make sure the data is in a known good state. And our solution does that out of the box without you having to worry about anything. Once the settings are set, you're actually going to click next. It's going to do a quick validation. The whole goal here is to get a whole bunch of greens. Some cases you don't get greens. If you get a red, that means it's an issue. You'll have to click on the information that's there and it'll tell you kind of what you need to do. You're not going to be able to move forward with any reds. Yellows are okay. They're just actually calling out different things. In this case here, it's just talking about the networking. Basically, it's saying that IPv6 is not supported GCP, but it is supported in AWS. So that's not a big deal. So these are not going to stop anything from migrating the server. Click finish and it's going to kick off the process. What's basically going to happen now, it's going to say, okay, I need to start moving data that exists already on disk, and that's a mirror. All right, we do it logically. We actually do an internal block checksum processing so that if the data on the target already exists in certain areas, we're actually only going to catch up the differences. Now, at the very same moment, what's happening is that we've activated our replication engine, which is going to take the data that's happening in real time to the data volumes, capture it, package it, ship it across the wire, ensure order of delivery. So we're actually moving data two different ways at the initial onset of the job configuration, mirroring and replication. Now, once the mirroring is completed, it's going to stop. It's going to be idle. The only time it would kick in again is if for some reason you reboot the servers or something like that. It's going to automatically engage itself because we're not sure what might have changed outside of our awareness. So we're going to just confirm, we're going to do a consistency check of the source to the target and get the data across the wire as quickly as possible. Now, if you look at the bottom of the screen here, you can see a couple things going on here. Data to be moved, what has been skipped. So what I have done prior to this is I've already set up the job before, so it's actually skipping. It's not going to skip everything, but this gives you an example of that. If you preload the target data, it's going to understand what needs to be changed, and if it's good, it doesn't have to change on the target. We're not going to ship it across the wire. We're actually going to skip it. The bottom of the screen here just shows you a couple things with the compression. I mean, we're not getting great compression because there's really not much on the system, but typically you're going to get anywhere 50 to 70% compression depending upon the data types. Now we're going to just let this thing run for a little bit so it gets to synchronization complete. For the sake of time, I'm going to actually accelerate the video. 68%, 71. Now keep in mind, as this is going, the system is completely active. And if you recall, we actually removed a folder from the replication. So I'm going to go to the target system here. I'm just going to do an ls, or I should say a dir. Let's go back to root. So you know where I am. Okay. So we're on root here. Okay. I'm going to go to the source system, which is root as well. Okay. Now, as you can see in the screen here, you have the data folder here. You do not have the data folder on the left. Okay. So we've actually fully excluded that from the replication. So we're sitting at 77%. Let's give it a little wait-see here. All right, so we are at idle for the mirroring. Replication is ready. You'll see ready or replicating. That tells you that's doing something. At this point in time here, I can cut over any moment. So what I'm going to do is select the cutover button and say cut over to live data. What I'm going to do as well is jump into the screen for the CentOS box. So what's going to happen is that it's going to instruct the system to shut down. Most cases it happens immediately. In some cases it will be a little paused here, but in essence what's going to happen is we're going to do a cut over to the new system. Part of the process is going to take the volumes on the target. The data is being replicated to hidden folders. Once that information has been remounted to itself, the target system is going to reboot. So if I were to see if the machine is still online, it is. So what's going to happen in a moment here, it's going to complete its process. So the system's going to go away, and then it's going to come back, and it's going to take on the characteristics. So it's going to be CentOS at AWS. So give it a moment. All right, so it's failed over. And now what we're doing here is we're waiting for the login to commence. And here we are. Okay, so you can see it's running in Google. It has the AWS source name, has the Google IP infrastructure, and the migration is complete. Hope you find this beneficial. If you have any questions, reach out to our team. We can help you through your migrations. Thank you and have a great day.